You ever wonder how planes fly safely in bad weather? I'm talking about freezing rain, sleet, the kind of stuff that would ground a garbage truck. It's all thanks to anti-icing systems, those hard-working parts that most folks never think about. They're the unsung heroes of aviation, keeping flights smooth and safe when the weather turns nasty. Without these systems, ice would build up on the wings, tail, and other critical parts. That's bad news because ice disrupts airflow, making it harder for the plane to stay in the air. It's like trying to drive your truck through a blizzard with a sheet of plywood for a windshield. Anti-icing systems work by preventing ice from forming in the first place. They're like the guys who salt the roads before a snowstorm. They use different methods to do this, but their goal is the same: to keep those planes flying safely. In the next few sections, we're going to take a closer look at how these systems work and why they're so important. We'll get down and dirty with the different types of systems, the parts they protect, and the methods they use to keep ice at bay. So, buckle up, because we're about to take a crash course in Anti-Icing 101. Now, there are two main types of anti-icing systems, thermal and chemical. Each one tackles the ice problem in a different way, kind of like how you'd use a blowtorch versus a bag of road salt to clear your driveway. Thermal anti-icing systems use heat to prevent ice from forming. Think of it like a car's defroster, but for the entire plane. These systems come in two flavors, fully evaporative and running wet. Fully evaporative systems crank up the heat, turning any water droplets that hit the plane into steam before they can freeze. Running wet systems, on the other hand, use less heat, just enough to keep the water in liquid form so it doesn't turn into ice. Chemical anti-icing systems, on the other hand, use special fluids to lower the freezing point of water. They work by mixing with water droplets, making it harder for them to freeze. These fluids are like antifreeze for your car, but instead of keeping your engine from freezing, they keep ice off your plane. One common type of chemical system uses a fluid called TKS. It's sprayed onto the plane's surfaces, creating a slippery barrier that prevents ice from sticking. It's like spraying your car with cooking oil to keep the snow from sticking, but a whole lot more effective. Both thermal and chemical systems have their pros and cons, and the type of system used depends on the type of plane and the conditions it's flying in. Now that we know the types of systems, let's talk about where they're used on the plane. Anti-icing systems focus on the most important parts, the ones that are crucial for safe flight. First up, we've got the wings and tail. These big guys are responsible for generating lift and keeping the plane stable in the air. Ice buildup on these surfaces can be disastrous, reducing lift and making the plane harder to control. It'd be like trying to steer your truck with a flat tire. Not a good situation. Next, we've got the engine inlets, the openings where the engines suck in air. If ice clogs up these inlets, it can choke the engine, leading to a loss of power. That's why these inlets are equipped with anti-icing systems, usually in the form of hot air that prevents ice from forming. Then there are the pitot tubes and other sensors, which provide the pilots with vital information about airspeed, altitude, and other critical flight parameters. Ice on these instruments can give false readings, leading to dangerous situations. That's why these sensors are also heated to prevent ice from messing with their accuracy. And of course, we can't forget about the windshields and propellers. Visibility is key for safe flight, especially in bad weather. Windshield wipers and de-icing systems work together to keep the pilot's view clear. Propellers, on the other hand, need to be ice-free to function properly. Ice buildup can reduce their efficiency and even cause damage. Section 4, how heat keeps ice away, bleed air, electric heat, and special fluids. Okay, we've talked about the types of systems and the parts they protect. Now let's dive into how they actually work, focusing on the different methods of heat application. One common method is using bleed air, which is hot air bled from the plane's engines. This hot air is then ducted to the wings, tail, and engine inlets, keeping those surfaces warm enough to prevent ice from forming. It's like having a built-in hairdryer for your plane. Another method is electrothermal systems, which use electric heating elements embedded in the plane's structure. These elements work like the heating coils in your oven, gently warming up critical surfaces like pitot tubes, sensors, and windshields. They're especially useful for smaller components that don't need a blast furnace of hot air. Finally, some aircraft use fluid anti-icing systems, which spray a special de-icing solution onto the plane's surfaces. This solution works by chemically breaking down ice, preventing it from sticking. It's like using a de-icer on your car windshield, but on a much larger scale. Section 5. Conclusion, anti-icing for safety and smooth flights. So there you have it, a crash course in aircraft anti-icing systems. We've covered a lot of ground, from the different types of systems to the methods they use to keep ice at bay. But the most important thing to remember is that these systems are essential for safe flight in icy conditions. They're like the unsung heroes of aviation, working tirelessly behind the scenes to keep those planes in the air. So the next time you're flying in bad weather, take a moment to appreciate the hard work of these anti-icing systems. They're the reason you're able to reach your destination safely and comfortably, no matter what Mother Nature throws your way.